Now we're going to be working with equations involving rational expressions and solving equations with rational expressions. We're going to call this part of the tape part 1. So let's call this solving part 1. Okay. We need to remember what you did earlier in an earlier chapter of the course or of the book when you were working with linear equations which have denominators. For example, when you worked with a linear equation plus x plus 4 over 5 equals 3/5, remember that what you did common denominator, and you multiply both sides of the equation by that lowest common denominator in order to eliminate the denominators. So we'll take the lowest common denominator, which in this case includes the 3 times the 5, so we have 15. And what we're going to do is we're going to take 15 then, the lowest common the right side of the equation. We'll use the distributive property in order then to use that lowest common denominator to eliminate all the denominators. The first term, notice that 3 goes into 15 5 times, and what we're left with is 5 times the quantity x minus 2. For the second denominator, the second expression, second term, 5 plus 4 equals the right-hand side of the equation. 5 goes into 15 3 times, and so we're left with 3 times 3, which would be equal to a 9. Okay. Now, the nice thing about this is that we were able to eliminate all of the denominators, and then it's just a matter of solving this simple linear equation. Well, when we have rational expressions, we'll do exactly the plus 2 equals 9, 8x equals 7, and then finally we get an x which is equal to 7/8. Okay, so we'll find the lowest common denominator, we'll multiply both sides of the equation by the lowest common denominator, and then so let's take an example with rational expressions. Suppose we have 6 over 5x minus 2 over 3x equals a minus 8 over 45. This is we're going to find the lowest common denominator. Factor each of the denominators and find the LCD. Well, for the first denominator, what we need is we need to have a 5 and we need to include the x. For the second denominator, it's already in factored form. We need to have a 3 and an x, but we've already got an x. The 45 needs to be factored, and you know that's 9 times 5, so it's 3 times 3 times 5. We need 2 3 factors. We've only got 1, so let's multiply by 1 more 3. We need a 5, but we've already got the 5. So the lowest common denominator is 5x. So now we're going to take the 45x, we're going to multiply by the left-hand side of the equation and take the 45x and multiply by the right-hand side of the equation also. Remember that when we have equations without disturbing the equality. One thing that we need to do is take a moment right over here. We need to reconsider the problem. When you're working with domain, if you have an equation involving rational expressions, at the end, whatever solution you have to come back and see if it is in the domain of the problem. Remember, we don't want zeros in the denominator, and so we don't want this denominator to be 0. That means we need to throw out the x equals 0. We can't use that. The same thing for this one. 45. Now then, we're going to use the distributive property for the equation right here. So we'll have 45x times the first term, 6 over 5x, minus 45x over 3x, and that equals the right-hand side, which is minus 8/45, and we're multiplying that by 45x. But at this point, all the denominators disappear. 5 goes into 45 9 times. The x's disappear. So we have 9 times x, which is 54. For the second term, 3 goes into 45 15 times. The x's disappear. Minus 15 times. So we have x's only on the right-hand side. We can solve this by saying 24 is equal to a negative 8x. And at this point, we can go ahead and divide by a negative 8 both sides. Remember, we want to solve for x, and so we need to divide by the entire the negative 8. Well, this gives us then a negative 3, and the solution for this problem turns out to be x equals negative 3. Now, let's go back and look at the domain of the problem. If you remember a little bit earlier, what we said was that the domain could not include 0, but the solution we have is not 0, and therefore that solution works well.